Dear friends, this is the lecture number 10 of current electricity. So in this lecture we discuss applications of Wheatstone bridge. In previous lecture we derived the balance condition of Wheatstone bridge, but in this lecture we discuss applications of a Wheatstone bridge. So what are the applications of Wheatstone bridge? It has two applications. One is meter bridge. Another one is post office box. Have you heard this word, post office box? Post office box is not in our syllabus. Even if when I was in my plus 2, it was not in syllabus. It is totally outdated device. It is not required to discuss. Now you feel relaxed that you have only one application, that is meter bridge. So this is an important part for board examination. Always comes in exam this question. Meter bridge. So now we discuss meter bridge. So what is this? This is a device. In physics there are many devices. Some devices we have discussed and some devices also we discussed. So this is a device. This device you will see in your practical lab. In practical lab, how it looks like? How is this device looks like? What is its function? What is its principle? What is the working formula to do the experiment in the practical lab? Everything we'll discuss in this video. And if you understand this video clearly, you will get double benefit. One is for board exam. Another one is for practical exam also. What questions we will discuss today for board examination? The same questions also are for your Viva in practical examination. So you will get double benefit. This is your experiment number comes to this meter bridge comes as experiment number 2 in the practical, as prescribed by the CBSE syllabus, as well as 3 and 4. 3 and 4, but now it's only 3. Okay, so experiment number 2 and experiment number 3 are based on this meter bridge, are the meter bridge devices. Now let's understand how this device actually looks like. You will see that in the practical lab. It's a wooden block, just like this. I'm drawing the figure here. See, this is, I'm trying to draw the 3D diagram, though my drawing is not good. So this is a wooden block. I am making it 3D. See, like this. Okay, so this is one wooden block. A long wooden block, you will see. Long wooden block. It's kept on the table of the practical lab. Then what is there? Why this is called meter bridge? One wire is connected here. This is the wire. I am just writing the name of the wire A, B. This wire is important. This is the main hero of this experiment. This wire. How much meter long? It's 1 meter long, 100 centimeter, 1 meter long. That's why the name is meter bridge. Viva's question in practical lab. You will get this question, why the name is meter bridge? Because the wire used here is 1 meter long, hence the name is meter bridge. This wire. This is the important wire here. And to this wire, how it is connected? The connection is done like this by thick copper strips. You will see thick copper strips are connected. Okay, these are the thick copper strips. See, are connected. One gap we will find here. Then to this side also, thick copper strips are connected. I'm trying to make it as much as possible good 3D diagram so that you can able to understand, because I am unable to show here the meter bridge. So there is, see, one gap also find here. Here one gap also you find. Gap means knots are there to connect other devices. One knot will be here, one knot will be here, here also one knot in between. The meter bridge looks like this. Okay, which I can do a good diagram. Okay, so this is the 1 meter long wire. How I know that this wire is 1 meter long? One scale is also fitted here to know it is 1 meter long. One scale. I am just setting the scale here. Okay, here will be one scale from this to this. Just parallel to it, one scale will be there. I am drawing a very narrow scale. Okay, this is the scale. Scale is fitted here to know that it is 1 meter long. Okay, this is the meter scale. Also fitted on the wooden block. This type of device you will get on the table of the practical lab, like this totally. Then how will do the connection to this device? How will do the connection? When you get this one, how will do the connection? You have to give current. Now you have to give current. How will you give the current to this device? See, you have to connect the cell. I am connecting cell here. See, here point I am writing. You have to connect one cell in the practical lab. From this point one knot will be here. From this knot you will connect a cell. Okay, this cell means it is battery eliminator. You will get also in that one in the lab. Some volt will apply. It's better if you apply 2 volt or 4 volt. 2 volt. It's better. If you apply 2 volt, it's better. Okay, as much less as voltage possible. Okay, 2 volt less, not more, less than that. So, at this point what will do? Resistance box will be given to you. One resistance box. This is the resistance box. Will be given to you. You will connect one resistance box. Okay, and here you will connect. This is the unknown resistance. This unknown resistance may be a wire. Which resistance you don't know, you will calculate. This is the purpose of this meter bridge. Okay, what is the purpose of this meter bridge? What is the device? It is a device used to measure unknown resistance. Device used to measure unknown resistance. This resistance is given to you to measure. Either wire or you will get one color code carbon resistor. What I have told you already, color code carbon resistor. But if you see the colors, you can able to calculate the resistances. Then what will measure? So actually in the lab, when they will give you that color code carbon resistor, they will cover it. They will cover by some cloth with using gum. Okay, they will cover so that you can able to see the colors. You will measure the resistance. After that, your teacher will open the cover and will calculate from the color the resistance and will match the data what you are calculated from the experiment and what is the resistance coming from the color code. Then accordingly you will give the mark in the examination, practical exam. So this is your all total meter bridge. And here what you do? Here galvanometer is connected. Then one jockey comes and touches here. This is the jockey. Jockey means it's just like a metal. Okay, on it one cover will be there, plastic cover will be there on it. Plastic cover. Here this point, this will be like this, and here one knot will be there. From the knot wire connected. This is the jockey. This one is totally plastic cover where you will hold it, and this pointer will slide on the wire. Jockey looks like this. Okay, this is the jockey. Okay, this pointer will slide on the wire. You slide on the wire. So it is another name. It is another name, that is slide wire bridge. This is also one virus question. Why the name is slide wire bridge? Because this pointer, this jockey slides on the wire. Hence it has another name, slide wire bridge. Remember, why meter bridge? Because this wire is 1 meter long. Why slide wire bridge? Because jockey slides on the wire. Then another thing is, another virus question will come. This wire is made up of what? This black color wire. The main hero of this experiment is made up of what? Constantan or manganese. That is made up of constantan or manganese. Why constantan or manganese? It is made up of why? Two reasons. First is why constantan manganese? Two reasons. First is because of high resistance, high resistivity. It has high resistivity means high resistance. This is a resistive wire, not like a conducting, but it has high resistance. Number two, very important. Alpha tends to 0. What is alpha? Just recall. We have discussed alpha RT equal to R naught whole into 1 plus alpha T. Temperature coefficient of resistivity. Resistance varies with temperature. Alpha positive for conductor, negative for semiconductor, we have discussed. But for constant and manganese like alloy, they are alloys. Their composition also you can able to see there. Sometimes that also comes as a question. Constantan is made up of what? Manganese is made up of what? Okay, that is also important. So that is the Kumar to you. You will tell me the compositions of constantan and manganese all with their percentage. Okay. So this is the alpha. Alpha for constantan and manganese is 0. This alpha. If alpha will be 0, then what will happen? If this tends to 0, then RT is equal to R0. Resistance doesn't vary with the temperature. Alpha tends to 0. Alpha not exactly 0, I made it 0 like that, but it's negligible. Very, very small, so resistance doesn't vary with the temperature. Why is it required? Why we are taking a wire where alpha is nearly 0? High resistivity is okay, it has resistance, but why is it required? Its resistance should not vary. Why? When you will do the experiment, what some students do, they switch on the device and chit chat with each other. At that time, current is passing through this wire. When you switch on this, one switch you can connect here, no problem. But switch also will be in the battery eliminator. But here we can connect on switch. So when you close the switch, current is passing through this wire. And when current passes through this wire, this is a resistance wire, high resistivity. Obviously, heat will generate. The wire will be heated. You can't toss the wire even if it will be heated. It will be then slag. It will be then slag. Slag, its length will increase. It will not be 1 meter length. Okay, it will be slag then. Another thing is also resistance will change. If resistance will change, then your experiment, accurate experiment you will not get, accurate data you will not get. Resistance varies with temperature. Now what resistance is there, after some time when temperature will rise, resistance will be different. Your data will vary. So this wire is chosen like that so that resistance doesn't vary with the temperature. But you should be cautious that temperature of the wire should not increase. While you are not doing the experiment, not taking the observation, you just switch off it. When you will take the experiment, observation you will take, you switch on, take observation, immediately switch off after observation. So keep in mind about this switch so that your data will not vary. If temperature will increase, then length will increase. It will be slag also, you will face the problem. Okay, so you try that temperature should not vary. So resistance, if temperature should not increase. If temperature will increase, then resistance, little bit resistance may vary. So only keeping in mind in that factor, we have taken alpha nearly 0 material. So now you got my point. Why constantan and manganese? high resistivity and temperature coefficient of resistivity nearly 0 means, simple language you can write, resistance doesn't vary with the temperature, almost doesn't vary with temperature. So this is important question, comes in exam. And we'll go to now. I already have told you what is the device, what is the purpose, to determine unknown resistance. Then concludes the principle. Principle is what? First, what is it? Then it's a principle. It is based on the principle of Wheatstone bridge. Wheatstone bridge. An exam question will come. Write the principle of meter bridge. It is based on the it is based on the principle of Wheatstone bridge. Either you will get 0 mark or you will get half mark. Why? You have to write this comes in the marking scheme of the board. You have to write it is based on the principle of balanced condition of a Wheatstone bridge. You have to write it like this. It is based on the principle of balanced condition. Balanced is very important. The word balance is very important. If you will rebalance, sir will leave mark. Okay. So remember this one. Principle is balanced. This one is important. Principle is balanced. Balanced Wheatstone bridge. Okay, this is the principle of meter bridge. Don't forget to write balance. I am telling you repeatedly this one. So next we will come to its working. Construction I have already told you. How we will take the observation and what is its working formula. Let's derive. It always comes in exam as a 3 marks question. Very important. Always comes in, repeatedly it comes in exam. It's a common question for board examinations. So to derive its working formula. How will derive working formula? How will take the observation? You see. This is the resistance box connected here. This is the unknown resistance connected in this gap. This is the galvanometer and this is the jockey. Jockey will slide on this. Where? So what you do first? Switch is here. Switch is on. Then the resistance, from the resistance box you will apply resistance. I hope all of you know about the resistance box. Its principles also. I am telling a little about it. Resistance box also looking like this. This is the resistance box. This is the box type. This is the resistance box. They are also looking like this. Okay, 2 points will be there. 2 points to these 2 points will be connected at this, and here will be the different resistances will be here. Resistances here, copper, thick copper strip will be here. Some between one gap will maintain between it. 3 copper strips will be here. Okay, maintaining gaps. See, I am explaining also what is this resistance box and what is this principle. Try to understand. Gaps will be there, and in this gaps it will be written. Suppose 5 ohm, 2 ohm, sometimes also 5,000 ohm, 10,000 ohm on the gaps, and on the gaps there will be one knob. Knob will be there in the gap. But when you, here will be one knob. I am drawing the figure of the knob, you see, by red marker I am drawing the figure of the knob. Okay, these are the knobs connected. Everywhere there are the knobs. Knobs are connected there. I am drawing the blue color, you see. Okay, here will be the knobs. Means all are connected now. So these are the thick copper conductors these are, and these are also knobs are also made up of copper. When current pass here, copper, again knob, all knobs are closed now. So all the gaps are closed. Current will pass just like this. Current will pass just like this. If current will pass just here on this meter base, its resistance is 0. No knob is taken out. No knob is taken out, its resistance is 0. But when you apply the resistance, when you take out a knob, suppose this knob you now take out. If this knob will take out, now gap is there. You have applied how much resistance? Just in the gap, how much rating? 5 ohm. Means you have applied 5 ohm. How? How when you take out a knob, then its resistance is 5 ohm. What is written there? That much resistance you are giving. Yes. When you take out the knob, what happens? I am showing you. You see these are the copper strips. You take out this knob. Then one conductor is inside this box. One coil is there. It is connected to this. This is 5 ohm. When you take out the knob, the gap is there. The path break. When path break, current has to travel through this resistance which is inside the box, which you can't able to see. Inside this wooden box, one coil is there which is 5 ohm. Now you apply 5 ohm. If another knob will take out, let's say near to it, you see. Suppose this is 2 ohm. Another knob you take out. This knob you take out. Again another coil is here. 2 ohm. Now current will go 5 ohm. Then again through 2 ohm. They are connected in series. Total will be 5 plus 2, that is 7 ohm. This is the principle of resistance box. Try to understand. Okay, well, not only you will use the resistance box in the practical lab, but you have to understand how it works. What is actually the principle of resistance box? 5 ohm, 2 ohm, so it becomes 7 ohm. So current actually, when you take out one of path breaks on the resistance box, so current has to travel inside it and passes through that resistance, so that much resistance is applied. Then the one question always students ask here, sir, when the knob was there, when the knob is here, also coil is there, then at that time current do not pass through that 5 ohm. No, at that time current will not pass through 5 ohm. Why? Because current always prefer low resistance path. Remember, current always prefer low resistance path. This is copper, thick copper, negligible resistance. Also this is copper, knob is also made up of copper. So current will pass like this. Though wire is there, current will not go because they are resistances. Current always prefer low resistance path. Here negligible resistance, so current will pass. Understand? So this is the principle of a resistance box. Okay. Now we come to our meter base. Now see what happens in the meter base. So you apply some resistance here. Suppose you apply the resistance R here. I am giving example. Not I am giving example. Suppose you apply resistance of 50 ohm here. If you apply resistance of 50 ohm, now what will happen? What will do after applying resistance? This wire will bring. It will use a long wire here because it has to move from this end to this end. This jockey will bring. This is suppose your jockey. Now this jockey will bring and touch here. It will touch here. You see. This is the galvanometer pointer, suppose. Okay, I am drawing the galvanometer here. This is your galvanometer. 0 here. Okay, this is your galvanometer pointer, and these are the small readings here there. Okay, this is the 0. So this is the pointer galvanometer you see, and this is the jockey. When you bring the jockey, this red marker is the jockey and the black marker is the galvanometer pointer. When you bring the jockey, touch at point A. Now see the galvanometer pointer. Take it, touch at B. Again I am telling, touch at A, touch at B. Connection is 100% right. Now you are satisfied, my connection is 100% right. So that means when I take the jockey from A to B, when I slide the jockey from A to B on the wire at A, like this. When you slide the jockey on the wire, you see to this galvanometer pointer. Your focus should be on this pointer. You see, this jockey is going A to B. Okay, jockey is going now. See what will happen. Can you mark? What happened? Galvanometer is showing 0 deflection when the jockey is here. If galvanometer is showing 0 deflection, this point is called a null point, and this is J. Jockey J and right here, this is the null point. Again I am doing, jockey is here, galvanometer pointer is here. Jockey is going, galvanometer pointer is going. See. Galvanometer pointer shows 0 deflection, jockey is here. If we take it forward, you will get like this. But we need the null point, so keep it here and measure the length Aj. you measure the length HJ. Okay, that from 0, you start from here 0, your measurement will start from 0. 0 we said resistance box is there, keep it that at 0. Measure the length HJ, then BJ is obviously 100 minus that much. This length is suppose L, then this is 100 minus L centimeter. So this is your experiment. Observation is this much. This distance you have taken R. You have taken at that time the distance you have taken R. Now is it Houston piece? It looks like Houston piece. Yes. Now see, Houston piece, completely Houston piece. How do Houston piece? See, I am drawing the Houston piece. Now you compare. This is my Houston piece. Okay. Galvanometer is here. So this is R, this is S, this is P, this is Q. This is Houston piece. Just I reverse the previous. I had written PQRS, but I am writing PQRS. Okay, no problem. I am writing like this. Okay, so here this is R, this is S. Compare. Galvanometer is here. And PQ, when this is the null point, this wire divides into 2. Means you divide the wire now to what to? HJ is one wire, BJ is one wire. Resistance of HJ is P, resistance of BJ is Q. Now you get this is the complete Houston piece. You understand? Okay. Okay. Now when this is jockey and null point means it satisfies the balance condition to Houston piece. No current passes through galvanometer. So we can write the formula R by S. R by S. P by Q means resistance of HJ by resistance of BJ. You can write resistance of HJ, resistance of BJ. Then R by S, resistance of HJ how much? That is rho L by A. Resistance of BJ how much? Rho 100 minus L by A. So rho A cancel because same way, same rho, same area of cross-section. So R by S, L by 100 minus L. So now you need S, R whole into 100 minus L by L. This is the working formula for meter gauge. I hope everybody understand now the working formula of meter gauge. So now this type of questions comes based on this. Questions comes based on this formula. You have also one book example, 3.9 example. You can solve. Meter gauge example always comes in exam. But when this derivation comes, what are the other questions attached to this? What other questions will be attached to this derivation? This is the complete derivation I am using now. What are the other questions attached to this derivation? First question, I have already told you, this wire is made up of what? Constantan and manganese, like alloy. Why? Because of high resistivity, low temperature coefficient of resistivity. Then other questions, various questions, also one more questions comes in exam, or many times comes in the board examination, very common questions. This red color, thick what I have done, these are the copper strips. Why thick copper strips are used? Only for conductivity, because they are negligible resistance. Why thick copper strips are used? Because their resistances are negligible. Only for connection they are used. Then, what other questions will come? When, this is important one. When meter gauge is said to be most sensitive? Answer is, when the null point comes at the middle of the wire. Middle of the wire means this length is 50, this length is 50. When the null point comes at the middle of the wire, then it is called most sensitive. Accurate observation it will give. Meter gauge is said to be most sensitive when the null point comes at the middle of the wire. Always try to take the null point at the middle of the wire. But it's not possible always to get the middle of the wire. If not possible, try to get the null point between 45 to 55 in your practical lab while taking observation. Don't take 100. Do not 100. It will not come 100. Don't take 90 and 10. Always 50, 50. Or this is 45, this is 55. or this is 55, this is always try to get the null point between 45 to 55. But how will I adjust that one? By this resistance box. Suppose this resistance box we are taking 50 ohm, but this unknown resistance is very less. Suppose 2 ohm. This one you don't know. This one you don't know. You are taking 50 ohm here. If you are taking 50 ohm, and this side resistance is more, means this side resistance will be more because the SU is constant. Okay, this is 50 by 2. This will be also more by less, means more by less. This length will be more. So what happens to your jockey? If this is your wire, you see, if this is your wire, if this is you are taking 50 ohm, this is 2 ohm, then your galvanometer, this is jockey will go and touch at this side. Means this side length will be 80, this side length will be just if you take the ratio, automatically you will get the length. Okay, this is 50 by 2, 25, accordingly you will get the ratio. This will be 80 or 85 like this will be less. 20 or 50 like this, yeah, you will get less. Don't write that observation because metrobus is not sensitive at that time. Don't write that observation. What you have to do, if it is going towards that side, means this resistance box you have taken more resistance, you decrease it by 25. You don't know this 2 ohm, by 25, then the jockey will come. If this will decrease this one, this length will decrease, jockey will come towards middle, null point will come towards the middle, again you decrease and keep it, suppose it is 3 ohm. Now it is comparable to that one or not? Very close. Now you may get the null point just 50 or more than 50. Okay, and take it now. Once you will get a 51 observation, just to slightly vary this resistance box so that you will get your null point always between 45 to 50, 45 to 55. You will get your null point. Understand? So this is about the meter base, its a principle, and how this comes as a question in the board examination. I also told you that 1 mark questions will be asked here. Another question also may come here. If cell and galvanometer are interchanged, what happens to the null points? Similar question just like the Houston base. If cell and galvanometer are interchanged, what happens to null point? What's the answer? It will shift or will not shift? Obviously it will not shift. Null point will not shift if cell and galvanometer are interchanged. There is no shifting of null points. Okay, so this is about the meter base, and you can try the book example 3.9. Then we'll discuss in the next video about potentiometer, which is a very important part. Thank you.